All right, hi everybody, and welcome to Unit 3. We're going to start talking about our phases. Some of this should be kind of a review from previous years and also from our previous units. So first off, matter has three phases that are characterized mainly by the arrangement of those particles, how they are arranged. Like we all know that there's solid, liquid, gas, and stuff like that. But what we are really going to be looking at is we're going to be going down on that particle level. So first off, in a gas, the particles are very far apart. And the particles really have no attraction for each other, which means if they're going to hit each other, they're not going to stick to each other. They're going to keep on kind of bouncing and moving randomly across the room. So they're going to move randomly, and they're going to take the shape of their container. So actually I'm going to I'll draw all three of these right now, and then we'll come back and and we'll go back to like the solid and liquid. So as we said, gas particles, so I'm just going to draw four particles in here. So gas is what we've been doing. We're going to say these guys have two wishies because they're going to have a high energy. So higher energy means the more wishies. The liquid, remember, these guys are basically going to be kind of forming the bottom of the container. And for these to be able to show movement, we're just going to kind of do like a little squiggle with them because they're not moving as fast or as randomly as gases are, and they're just kind of like flowing across. So this little kind of flowy wishy shows that they are flowing. And then solids, they are going to have a pretty rigid structure, so we have that there, and they're not moving freely, but they're going ahead and vibrating back and forth. So we'll show solids that how they are moving is with these vibrations next to each other. Okay, so we have our liquids. The particles are arranged somewhat close to each other. There's a little attractive forces, meaning because they can flow over each other. All right, so they can flow over. Let me just rewrite that so they can flow. And they're vibrating, moving, spinning, flowing, all that good stuff. And we're wanting you to explain the densities and compressibility of the three phases. Pretty much we're going to focus on the gas and the solid. Liquid is usually all in between. So think about back to Unit 1. And our density of a gas and our densities of our solids and stuff like that. So we found with our density of our gas lab that gas has the least density, or is the least dense, and solids are the most dense. Also, gases are the most compressible, meaning you can squish them down. And then solids, they're pretty much as small as you're going to get them. You're not going to really get them too much smaller. So these guys are the least compressible, meaning you can't make them much smaller. And if you look back at our previous picture, with our solids, they're all pretty much they're pushed right on top of each other. So you can't really make them any smaller. But gases, you see that there's a lot of space in between them. So you can go ahead and push the sides of those containers in, and you can compress it. Then we have our solid. And these particles are packed tightly together. They have attractive forces, and they are moving by vibrating. So they are vibrating back and forth. So we're going to draw a before and after picture of freezing water to ice. So we have our water, and then we have ice. So I'm going to stick with like 6 particles or so. So again, we're going to show our water. So we have our 1, 2, 3, 4, 5, 6. I'll show 7 in there just for the heck of it. And the easiest way to also make sure that we have that we're showing a liquid is to put that line at the top. And then to also show the kind of movement, we can just kind of put those little vibrating whooshies in there. So like a little one in there. And then ice. So we're going to take those same ones, and now they're going to be more compact. These should actually even be about the same. 1, 2, 3, 4, 5, 6. I need another one. So about the same size. And then we're going to show that they are now solid by the vibrating that is on the side. Phase changes. Easiest one to think of is with water, but really almost anything can undergo a phase change from that solid to that liquid to that gas. So melting is specifically going from a solid to a liquid. Evaporating is going from a liquid to a gas. Think about if you've left a glass of water in your room for a long period of time, and then you come back and all that water is gone. It has evaporated. Condensing is going from a gas to a liquid. So think about on a hot, humid summer day, you have a glass of ice water or lemonade that's really cold, and you bring that outside, and then all of a sudden there's water on the sides of that glass. That's because the water has condensed from the air onto the glass itself. So it has gone from that gas phase to that liquid phase. And then freezing is going from the liquid to the solid. So think about water forming into ice. And we're going to go ahead and draw a before and after picture of evaporating water to steam. So we have our water, and then we're going to show our steam. So I'm just going to go ahead. I'll draw like 4 particles. So 1, 2, 3, 4. We'll show a little vibration. Each particle has something that goes along with it. And then now for the steam, because that is a gas. So we have our 1, 2, 3, 4, and we have to show that it's going to have more energy, so we're going to go ahead and give it 2 whooshies to show that that energy has increased to go from the water phase to the gas phase. Because to be able to go from one phase to another, it has to have more energy or less energy. But in the case of going to water to steam, you have more energy. Okay, so now what we're going to start doing is we're going to be looking at these things called LOL charts. They're really fun. They're called LOL because, hey, we have an L, we have an O, and we have an L right here. So those are our LOL charts. So we're going to get really familiar with those. And these are really cool because it's an easy way to see the energy that is going to be transferred in between, in the systems and stuff. Because just like the conservation of matter, where matter has to be conserved, the energy has to be conserved. It has to go somewhere. So those energy bar charts, our LOL charts, are accounting for the energy storage and transfer in the system itself. So the system is what we are studying, okay? So our system in this case is going to be our O. So whenever we're talking about if something is going to be going into the system or out of the system, so if it's going out of the system, we use an arrow that way. If something is going into the system, we use an arrow that way. So that would show if something is going into or out of the system. And then the surroundings are everything that are outside the O. So it would be outside of the O itself. And then the energy is the quantity that has the capacity to change. And it is always, that is really important, it is always going to be conserved here. So we want to draw a phase energy for each of the phases. We're going to use standard that solid will always be 1 block. Liquid will always be 2 blocks because a solid has less energy than a liquid. And then a gas will always have a phase energy of 4 because the gas has the highest energy. So that is something that is going to be standard that we're going to use for all of our homeworks, all of our tests, all of our quizzes. So you just have to remember that solid has 1, liquid has 2, and gas has 4. And so solid is the least energetic and gas has the most energy. So phase energy, that's going to be the energy stored due to the arrangement of particles. And so that is the EPH. Okay? So in the change, the particles are going to move farther apart or closer together, and that's going to be that degree of freedom of the particles. Now thermal energy, so that's going to be the ETH. So that is your ETH over here, is going to be, think about thermal is thermometer, temperature. Okay, and that is going to cause the particles to move faster or slower. Okay, so phase energy is the particles moving further or closer together from each other, and then the thermal energy is their temperature, and these two will be kind of linked. And then chemical energy, this is the energy stored in the chemical bonds. We are not going to talk about this very much. And that's your ECH. We won't talk about that more until second semester, but what we're going to do is we're just going to use a standard 1 block for our chemical energy. So our ECH will always be 1 block. All right, that's the easiest thing to do. So that way we can account for our chemical energy that is stored in there. But we're pretty much for this unit, it is ignored. So it will always be 1 block. So what I want you guys to do right now is just go ahead and do a 3 to 4 sentence summarizing the main points that you took in your notes today. And that is it for phases in energy. Thank you very much.